This video is about sinusoidal transformations. That's a transformation of a sine or a cosine function. This is AP Precalculus topic 3.6. If you appreciate this content, please give it a like. Number 1. The graph of the sinusoidal function h is shown in the figure above. The function h can be written as h of theta is equal to a times the sine of b theta plus d. Find the values of the constants a, b, and d. One period of the parent function y equals sine theta looks like this. The full model for a sine function with all of the transformations includes a c value right here, and the opposite of c is the phase shift, or a horizontal translation. The fact that this model does not have a c value means that the c value must be 0. So there's no phase shift for h of theta. That means that one period of h of theta is going to begin right at 0. Copying the shape of the parent function, we know that one period of h of theta will look like this. This is the right side up version of the sine function, so the a value will be a positive number. The amplitude is the distance between the midline and the highest value. Since the amplitude is 3, then the a value is 3. Note that if we wrote an equation for h of theta based on this period of the graph, then the a value would be -3, because this period is upside down compared to the parent function. We have memorized that the b value is 2 pi divided by the period. One period of h of theta starts at 0 and ends at pi, so the period is pi. Therefore, b will be given by 2 pi divided by pi. The pi's cancel out, so b is equal to simply 2, which goes right here. Finally, the d value is given by the midline, which is y equals -1. So the d value is -1, which we will simply write as -1. There will be 4 free response questions on your AP exam. This problem is just like FRQ 3B Part 2. An answer box will be provided where you can record your values of A, B, C, and D. However, you may also choose to leave the answer box blank and record your answer as an expression for h of theta with the values of A, B, C, and D filled in, like this. Let's do the same thing again for problem number 2. Again, there is no c value, so the phase shift is 0. So I have traced one period of the sine function starting right at 0. This gives a right side up sine function, so the a value is going to be a positive number. In other words, the a value will just be the amplitude, which is 4. 6 minus 2. The b value is given by 2 pi divided by the period. In this case, the period is 8 because we see that one period goes from 0 to 8. That means the b value is equal to 2 pi over 8. This reduces down to pi over 4. And the b value goes right here. Since the midline is y equals 2, the d value is +2. You can record your answer like this or like this. We can already tell that the value of c is 0. So let's find the values of a, b, and d for the function g of theta. Since the c value is 0, the phase shift is 0. So one period of the sine function will start right here at 0. If we trace out one period, it looks like this, which is upside down compared to the parent function. Therefore, the a value is going to be a negative number. Specifically, it will be the opposite of the amplitude. The amplitude is the distance from the midline to the maximum value. That's 15. 20 minus 5. So the a value is negative 15. We have memorized that the b value is 2 pi divided by the period. In this case, the period is pi over 2, because the first period goes from 0 to pi over 2. Therefore, the b value is going to be 2 pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. Therefore, b is going to equal 2 pi times 2 over pi. The pi's will cancel out because you have one low and one high. So that's going to leave 2 times 2, which is a b value of 4. And that 4 goes right here. And because the midline is y equals 5, the value of d is positive 5. You can record your answer like this or like this. Number 4. The figure shows the graph of a sinusoidal function h. What are the values of the period and amplitude of h? The period is the length of one cycle of the function. And here's one period of the cosine function, from 0 to pi. So the period is pi. The amplitude is the distance between the midline and the highest value. In this case, the amplitude is 2, 3 minus 1. So, the answer is A, which says that the period is pi and the amplitude is 2. Number 5. The trigonometric function k has a maximum at point 0, 8. After this maximum, the next minimum occurs at the point 2 pi, 2. Which of the following could be an expression for k of x? We have learned that the horizontal distance between a maximum and the next minimum is always half the period. We can think of the horizontal distance between consecutive max and min as theta 2 minus theta 1. So 1/2 the period is equal to theta 2 minus theta 1, the input values of the max and min. Multiplying both sides of this equation by 2 gives us the equation period is equal to 2 times theta 2 minus theta 1. Let's use this equation to find the value of the period in problem number 5. We are given the coordinates of consecutive max and min. The input values are 0 and 2 pi. So the period will be 2 times theta 2 minus theta 1. That's 2 times 2 pi minus 0. Obviously, the 0 doesn't really matter here, so the period is just 4 pi. We have also memorized that the b value is 2 pi divided by the period. So in this case, the b value is going to equal 2 pi divided by 4 pi. The pi's cancel out, and 2 over 4 reduces to 1/2. So that narrows it down to options A and C. These are the only ones that have a b value of 1/2. It will be easy to choose between option A and option C because A is a cosine function while C is a sine function. And we know that a sine function always starts at the midline and cosine doesn't. Options A and C both have a d value of 5, so the midline is 5. Both functions have an a value of 3. That means that the amplitude will be 3. Adding or subtracting the amplitude from the midline gives us a high of 8 and a low of 2. We notice that in both cases, the c value is missing. The c value is 0. Therefore, there is no phase shift. So both of these functions should start right at 0. But we are told that function k has a maximum at the point 0, 8. In other words, the function starts at a maximum, The sine function always starts at the midline, so the answer cannot be a sine function. The answer cannot be C. The answer must be A, which makes sense because a cosine function with a positive A value will start at its maximum value, which in this case would be the point 0, 8. Number 6, the trigonometric function k has a maximum at the point pi over 2, 30. After this maximum, the next minimum occurs at the point 3 pi over 2, 20. Which of the following could be an expression for k of x? Given consecutive max and min, we know that the period will be 2 times the horizontal distance between max and min. However, we don't need that this time because the point of this is to ultimately give us the value of b, and in this case, all of the options have the same b value. b is equal to 1, so that doesn't actually help us out. We do see a couple of different values of d among the options, and the d value corresponds to the midline. So let's calculate the midline so we can eliminate 2 of these options. The midline is always y equals the average of the maximum value and the minimum value. So y equals max plus min divided by 2. In this case, the maximum value is 30 and the minimum value is 20. So the d value will be 30 plus 20 divided by 2. That's 50 divided by 2, which is 25. So we can eliminate options B and D, which have the wrong D value. I really wanted to calculate the amplitude to help us choose between options A and C. However, the amplitude corresponds to the A value, and these both have the same A value, so the amplitude won't help us choose. However, what's different is that option A is cosine, while option C is sine. So let's sketch a graph based on what we know and see if the picture turns out to match a cosine function or a sine function. We know that the period is given by 2 pi divided by the b value, but in this case the b value is 1. So the period is simply 2 pi. Neither of these options have a phase shift. The c value in both cases is 0. So the period will begin at 0. Since the period is 2 pi, then one cycle of either function will end right here at 2 pi. The halfway point will be pi, and half of that is pi over 2. This is 3 pi over 2, if you're curious. Options A and C both have positive A values, so we will sketch the right side up versions of sine and cosine compared with the parent functions. Let's start with option A, the cosine function. One period of the cosine function with a positive A value is going to look like this. Will we have a maximum value at pi over 2? I think not. The cosine function will be on the midline at pi over 2. On the other hand, the version of the sine function that corresponds to a positive A value looks like this, which does have a maximum value at pi over 2. So the answer is C. Number 7, the trigonometric function k has a minimum at the point 0, -6. After this minimum, the next maximum occurs at the point 3 pi, 0. Which of the following could be an expression for k of x? All of these options have a d value of -3, so the midline is y equals -3. We are also given that the minimum value is -6, while the maximum value is 0, so I've included that on my sketches. We can see that in every case, the c value is 0. There is no phase shift. So one period of any of these options will be starting right at 0. I just realized that these are all cosine functions, So it's either going to be a right side up cosine function with a positive a value or an upside down cosine function with a negative a value. Only the upside down version of cosine will start at a minimum value, 0, negative 6. So we can eliminate options A and C. We can decide between the remaining two options by calculating the b value and then seeing which one of these is a match. However, to find the b value, first we need the period. We have learned that the period is always double the horizontal distance between consecutive max and min. In other words, the period is 2 times theta 2 minus theta 1, where theta 2 and theta 1 are the input values of consecutive max and min. So in this case, the period will equal 2 times 3 pi minus 0. Ignoring the 0, we find that the period is 6 pi. The b value is given by 2 pi divided by the period. So in this case, the b value will be 2 pi divided by 6 pi. The pi's cancel out, and 2 over 6 reduces to 1/3. So the answer is D, because that's the option that has the correct b value. Number 8. In San Diego, the number of daylight hours is dependent on the day of the year. The number of daylight hours, D, can be modeled by the sinusoidal function d of t, which equals 2.4 times the sine of 0.017 times t minus 81 plus 12, where t is the day of the year from t equals 1 to t equals 365. Based on this model, which of the following statements is correct? Based on the d value, the midline is y equals 12 hours. So the maximum number of daylight hours will not be 12. The minimum number of daylight hours cannot be 12. This is sort of the middle number of daylight hours. So we can eliminate options A and B. If the midline or average number of daylight hours is 12, then the maximum number of daylight hours can't be 9.6, so option D is out. We can see that the answer is C, which makes sense because the minimum number of daylight hours should be 2.4 hours less than the average number. 2.4 is the amplitude, and the minimum number of hours should be the midline minus the amplitude, which is 9.6. Number 9. The figure shows the graph of a sinusoidal function g. Write an equation for g. It will be easiest to write a sine equation for g of theta, since the period they gave us matches the parent function for sine theta. We notice that this period starts right at 0, no phase shift. So we can go ahead and put in 0 for c, which simplifies the model that we are shooting for. We just need to find the values of a, b, and d. This period has the same orientation as the parent function, so the a value will be a positive number. Specifically, the a value will match the amplitude. Be careful, we are not counting by ones on the y-axis. The amplitude will be the highest value minus the value of the midline. In this case, the amplitude will be 4 minus negative 2. That's the same thing as 4 plus 2, so the amplitude is 6. Therefore, in this case, the a value is 6. The b value is 2 pi divided by the period. In this case, we notice that the period is 4 pi. So b will equal 2 pi divided by 4 pi. The pi's cancel out, leaving 2 over 4. So the b value reduces to 1/2. And we slide the 1/2 right in here. Finally, the d value just comes from the midline. So we finish off the equation with a negative 2. Number 10. The function f is given by f of x equals 2 sine 2x plus 1. Which of the following could be the graph of f of x? Based on the d value, the midline is y equals 1. So option B is out. Function f has no phase shift, so we are looking for a graph that looks like the parent function for sine right from the start. Option D looks like a cosine function, so D cannot be the answer. We can find the period to choose between the remaining options, and the period is equal to 2 pi over the b value. So in this case, the period will equal 2 pi divided by 2. That's the b value. Therefore, the period is going to be pi. The 2's cancel out. Option A is the one that has a period of pi. So the answer is A. Number 11. The figure shows the graph of a trigonometric function g. Which of the following could be an expression for g of x? The b value is 2 pi divided by the period. We can tell that one period of this function is pi. So the b value is going to be 2 pi divided by pi. So the b value is 2. All of these functions have a b value of 2 except option A. So the answer is not A. Option A was the only one with no phase shift. So let's try out the phase shift one at a time and see which one is a match. Option B has a c value of negative pi over 2. That means a phase shift of positive pi over 2. That means we're talking about a sine function that starts right here. In that case, the first period of the sine function would go like this. This is upside down compared to the parent function, so the a value would be negative. The b option does not have a negative a value, so b cannot be the answer. Option C also has a phase shift of positive pi over 2, so we're looking at the same period. However, option C does have the negative a value, which matches this upside down orientation compared to the parent function. So the answer is going to be C. Just for the sake of completeness, option D has a phase shift of positive pi, so that first period would start right here and then look like this. This has the same orientation as the parent function, so it corresponds to a positive a value. But we notice that option D has a negative a value, so that's why D could not be the answer. Number 12. The graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. The coordinates of the 5 points F, G, J, K, and P are given here. The function h can be written in the form h of t is equal to a times the sine of b times t plus c plus d. Find the values of constants a, b, c, and d. By the way, there will be 4 free response questions on your AP exam. This question is just like FRQ 3B Part 2. Let's build an equation for h of t, filling in the values of a, b, c, and d as we go along. I'm going to write my equation for this period of h of t right here. This period has the same shape as the parent function, so there will be a positive a value. The a value will equal the amplitude, which is the highest value minus the middle value. So 7 minus 3 gives an a value of 4. So we will have a positive 4 right here. It's time to find the b value, but in order to get the b value, we need the period. From maximum to maximum, we are going from an input value of 0 to an input value of 12. That means that the period must be 12, or 12 minus 0 is 12. The b value is given by 2 pi divided by the period. So in this case, the b value will be 2 pi divided by 12, and 2 over 12 reduces to 1 over 6. So the b value will be pi over 6. Now it's time to find the c value, but the c value is the opposite of the phase shift, which is the first input value. So let's find the coordinates of this point right here as well. Notice that the input values are increasing by 3. So if I go to the left, I'm going to get 0 minus 3, which is negative 3. And this is on the midline, so I might as well say negative 3, comma 3, like these other values. With a phase shift of negative 3, the c value will be positive 3. Finally, since the midline is y equals 3, notice the output values of 3, that means that the d value is 3. You can record your answer like this or like this. Number 13 is the same problem with different coordinates. This is still a sine function, so I'm going to write the equation of this period of h of t. This period is right side up compared to the parent function, so the a value will be a positive number. Specifically, the a value will match the amplitude, which is the highest value minus the middle value. So a will be 20 minus 16, and that gives us an a value of 4. From maximum to maximum, the input values go from 0 to 4 pi. So the period is 4 pi. We know that the b value will be 2 pi divided by the period. So that's 2 pi over 4 pi. The pi's cancel out, and 2 over 4 reduces to 1/2. So that's the b value. Next, it's time for the c value, but this is the opposite of the phase shift, which is the first input value. So what are the coordinates of this first point? I notice that the input values are increasing by pi. So if I go one space to the left, then my input value will be negative pi. And this is on the midline, so this point has the coordinates negative pi, comma 16, like the other midpoint values. But the input value of negative pi is the phase shift. So the c value will be positive pi. The d value is going to come from the midline, which is y equals 16. So the d value is 16. You can record your answer like this or like this. For number 14, we will practice this same problem one more time with these new coordinates. We are still modeling a sine function, so I will once again use this period of h of t with a positive value for a, so I can find the a value by finding the amplitude, which is the highest value minus the middle value. So 2 minus negative 1, which is the same as 2 plus 1, which of course is equal to 3. So the a value is 3. From maximum to maximum, the input values go from pi over 2 to 3 pi over 2. So we can find the period by subtracting 3 pi over 2 minus 1 pi over 2, which is equal to 2 pi over 2, or simply pi. We know that the b value is 2 pi divided by the period. So b will be 2 pi over pi, but the pi's cancel out, giving us a b value of 2. The c value is the opposite of the phase shift, so let's find the coordinates of this point. Notice that pi over 2 is like 2 pi over 4. So we have 2 pi over 4, 3 pi over 4, pi here is like 4 pi over 4, and then 5 pi over 4. So we are increasing the input value by pi over 4 each time. So if we count backwards, we have 4 pi over 4, 3 pi over 4, 2 pi over 4, and 1 pi over 4. So the input value is pi over 4. Of course, the output value is the same as these other values that are on the midline, which is -1. The input value of the first point is the phase shift, and the c value is the opposite of the phase shift, so the c value is negative pi over 4. The d value comes from the midline. The midline is y equals -1, so the d value is -1. You can record your answer like this, or leave it like this. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.